Hi and welcome back to my channel. This week's problem is the problem you can see on the screen, and it's finding the area of the blue circle. Now this circle is trapped by two lines cutting through the square. Now these lines basically they trisect, cut into three, the right angle at the bottom left of the square. Now that circle is tangent to the sides of the square and to these lines that trisect that right angle at the bottom left. Now we've also got, as you can probably see, as you can probably recognise, you can definitely see it, a quarter circle going through this square. Now that just helps you in a few ways, which you're going to see later on in my solution, but it might also help you with your solution. So I'm not going to give anything away just yet. Now if you haven't already, consider subscribing to the channel because I show you how to solve a new problem every week, Monday at 5 p.m. So if you think this might be the type of videos that you want to watch, or you watch and you haven't subscribed, please do consider subscribing. Now without further ado, I'm going to show you my solution in 3, 2, 1. Okay, now the first thing that you want to do with circles or with a problem like this is to, first of all, write the angles on. It's trisected, so that's 30 degrees, and then put the radii on for the circle to your key points. So that is to all of the sides or the lines that are tangent to the circle. Now the next thing for that is label some of those lines, all of them if you want to, but I was cautious about cluttering up the diagram. R for my radius, and I've got my right angles there. So a radius meets a tangent at 90 degrees. So these will all be right angles. Now there are more right angles on there, but again, didn't want to clutter up the diagram. The next thing I did, now you might do this a different way, but the next thing I did in my initial solution is to put this line in, and that is going to perfectly cut in half this square that is made from two of my radii on the top right of the large square. So that's a diagonal, and I can work that out using Pythagoras. So that gives me, using Pythagoras, a length of that diagonal of r root 2, or square root 2r squared. Now from there what I did is I wanted to work out this line, and that's the rest of the diagonal going across the square. And as you can probably see, I've labelled some sides of a triangle here, 10. Now that side has to be 10 that I've labelled because that is a radius of the large quarter circle, and which is also the length of the square. And we have also got that the side that I labelled R going from the centre to meeting this tangent line. That has to be R because it's the radius of the circle. Now I can then work out the length of that diagonal by doing square root of 10 squared plus r squared, which gives me square root of 100 plus r squared. Now those two things added up have to be the length of the diagonal of the square, which I can work out because we know it's got a side length of 10. So that gives me, by again using Pythagoras, a full diagonal length of 10 root 2. So if I add these two things up, I get this, square root 100 plus r squared plus r root 2 is equal to 10 root 2. And what I want to do from there is I'm going to collect the root 2's on one side, 10 root 2 minus r root 2. I can then factorise the root 2 out. So I get root 2 brackets 10 minus r. I can then square both sides. So I get 100 plus r squared equals 2 brackets 10 minus r squared. Expand that bracket, and I'm going to get this. Okay, r squared minus 20r plus 100. Multiply out the 2. 2r squared minus 40r plus 200. Get everything onto one side. So 0 equals r squared minus 40r plus 100. And then I'm going to use the quadratic formula to solve it. So I've got this, which gives me two solutions. R is 20 plus or minus 10 root 3. Now, when you calculate this, what we get is that actually the only possible solution is 20 minus 10 root 3. And that is because 20 plus 10 root 3 is greater than 10, and we can't have r being greater than the side length of the square. Just visually that doesn't make sense, but also we'd end up with a circle which is going to be larger than the square essentially. So that's obviously not going to work with our diagram. So the only possible solution is 20 minus 10 root 3, and you might have got that with a different method, and you might have got that in a much quicker way. I noticed that after my initial solution, but this is the way that I initially did it, so I wanted to share that with you. But if you can find that other solution, put it down in the comments below. The other way of getting r is 20 minus 10 root 3. You can do it a lot quicker. Now a is pi times the radius squared. So we substitute in our r and we square it, which gives us this. Simplify it and we get this. And that is the exact form for the area of the blue circle, which ended up being quite neat, I think. Now, an extension to this problem, if you did want to have a look at something like that, is, well, you couldn't really do it by bisecting the angle or splitting the angle into 4, because then you wouldn't have a symmetrical way to trap the circle between two of the lines. But what about if you split it into 5, into 7, into 9? What happens to the area or the radius of the circle? Is there some kind of relationship there? That would be an extension to have a look at if you're interested. Thank you for watching, and as I said earlier in the video, if you haven't subscribed and you enjoy my videos or you enjoyed this video, please do consider subscribing, and if you enjoyed this video, please drop a like on the video so that I know you enjoyed it. Thank you for watching, have a great week everyone, and I will see you next week for another video. Till then, bye bye. Bye bye. Other hand. Always forget that, always do the wrong hand. Anyway, see you later.